Hey guys, welcome to the new video. Today we would be discussing on throttling. In my last video I have discussed on rate limiting and throttling, what is the difference between both, what are the different rate limiting algorithms, when and where it is applied and stuff like that. Today we would be discussing on throttling. So let's start. Rate limiting is just a policy that we are setting, but then throttling means we take certain actions. Once that policy is breached, once that threshold is breached, we are taking certain actions. That is what throttle means. So throttle means, let's take this thing, takes action on request when a threshold is reached. In this thing, two important keywords are there, action and threshold. So now what action means? Some action we are taking. What is that action? So there are three kinds of an action primarily. Hard throttle, soft throttle, and then hybrid throttle. What does hard throttle mean? So let's say 500 requests per second is what my rate limiting policy is. Suppose 500 requests per second, if I am getting let's say 501 or 510 requests, all the further requests I am going to throttle means I am going to delete, I am going to decline that request, and for that I am going to send 429 HTTP status code. So whenever you are receiving a 429 HTTP status code from a server means you are sending too many requests and they are throttling, they are declining their request and they are saying you like, hey, my server is currently busy, don't send me too many requests. So that means hard, means like declining the request. Then comes the soft throttling. Soft throttling means, okay, I am not declining the request. Let's say 500 requests per second is there and I am getting let's say 520 requests. So 500 requests for that particular seconds I am serving. What about the 20 requests? That 20 requests I am saving it in a queue. I am shaping the traffic. I am okay with delaying the response, but I am not hard throttling them. I am not declining. I am just keeping them. I am accepting and I am keeping them. Initially, if they are getting, let's say, response in 1 second, now they can be getting a response, let's say, in 2 seconds. A hypothetical example, but I am not declining the request. This is what soft throttling is. Coming to the final part, hybrid, which is a combination of soft and hard. Soft throttling means, okay, I am keeping the request in the queue, but then there is a chance my queue is getting overflown. If my queue size is, let's say, this is my queue, and if my queue size is let's say 20 requests, I can accommodate. If I can accommodate 20 requests and if I am getting let's say 30 or 40 requests, my queue is overflown. What am I going to do? I am going to hard throttle them. I am going to decline that request. That is what hybrid throttling means. Now we discuss on the action part. So whenever now in future I am going to say like, hey, we are going to throttle the request, assume we are going to do one of these things, hybrid, hard or soft throttling. Now these are the dimensions. Dimensions means, okay, till now we were always listening to like, okay, request per second, request per minute. Most of the time, like 90-95% of the time, we always hear these things only. Like, okay, after this many number of requests we throttle, but is it the only criteria? Dimensions means these are the different criteria based on which I am going to apply the throttling. It is not just purely based on the request, but there are multiple criteria. So first is request. We already know request per second. Then there is a burst limit. Let's say I am saying like 500 requests per second. So this is my 500 requests per second. Over and above that, what I am saying is I can accommodate a small burst. So let's say this is again like 500. So 1000 requests per second I am getting and I am able to accommodate this. So this is the burst. So till now I am allowing 500 requests per second. Suddenly there is a spike and I am getting 1000 requests per second. So I am allowing that. But here you see I am getting let's say more than that. Let's say I am getting 2000 requests per second. So for this my system is not ready. So these requests I am going to throttle. This is what burst limit means. Then comes the concurrency. Concurrency, 200 concurrent requests only I am going to allow. It has nothing to do with the request per second, request per minute. No, 200 at that particular milliseconds. Only these many requests I am going to allow. More than that, if I am getting requests, concurrent requests, hitting the same resource at the same time, I am going to just decline that request. Then comes the bandwidth, bits per second. For an example, 3 megabits per second. So one thing you need to understand, like always the network bandwidth is calculated in bits per second, not bytes per second. Let's say you are uploading an Instagram video and there is an upload bandwidth and a download bandwidth. Let's say upload bandwidth is 50 megabits per second and download is 100 megabits per second. So more than 50 megabits per second request if you are uploading the data. So then in that case, those videos would get throttled then. That is what bandwidth based throttling means. Then comes the CPU and memory. So assume we have an auto scaling policy. We have heard like, okay, if my CPU or memory is reaching 80% or 70% of my total capacity, then I should scale up the pod. Similarly, it happens like, okay, if my CPU or memory is reaching that particular threshold, then I should start throttling. This is again one of the policies that can be set. Then the error rate. It tells like, okay, out of let's say 100 requests I am sending, if 2% of the requests are getting failed, means there is some issue and start throttling my further requests. The more the requests you are giving to the server, the more the error rate. It can happen like, okay, server is overloaded or whatever happens, and if your server is able to let's say serve 100 requests per second and if you are giving them let's say 110 or 120, then your server is not able to handle the other requests and those requests are getting declined. So now the error rate increases, and as and when you increase more requests, the more error rate you would be starting getting. That's the reason based on error rate we are setting like, okay, if total number of requests that I am sending, if out of that 2% is the error rate, then start doing throttling. So that is again one of the policy. Then comes RTT, that is response turnaround time. Response turnaround time means client is sending a request to the server is doing a processing, and server is sending the response. So the time taken by request sending, processing and sending the response, including network lag and everything, that is response turnaround time. The more the response turnaround time means server is now choked, server is having too many requests and he is not able to serve too many requests. So if the response turnaround time is increasing, means again like, okay, there is something happening wrong at the server side and we should just throttle the further request. One thing that we need to understand is always there is an assumption like, okay, throttling always happens at the server side, but no, it is not correct. So here you can see dimension is set by user or monitored by the system. So it can be static or dynamic, that we would be discussing now. But once the threshold is reached, requests are throttled. They can be throttled at the client side or they can be throttled at the server side. Both the cases. Client side, assume like you are watching a video is being requested to the server, but your client is going to throttle. Your mobile application is going to throttle. That is what client side throttling means. Server side means, okay, you are requesting something to the server and server is choked and server is not able to serve because of any of the criteria, and server is sending you 429 or whatever it is. Then that is throttling that is happening at the server side. Again, whenever I am saying throttling, imagine those action points: hybrid, hard and soft. These are like different strategies a company can apply for them whenever they are saying like, hey, my system is going to throttle the request. So now final thing we would be looking into, how does the throttling work. So now till now we see what exactly is the meaning of throttling, what actions we take whenever we are saying like we are going to throttle the request, what all the different criteria are there, and now finally how it works. There are two types mainly, static and dynamic. Most of the times, and again like 90% of the time, this is an assumption like, okay, based on certain rate limiting policy only we are doing a throttling. So if my rate limiting policy threshold is breached, I am going to throttle the request. That is a static type of throttling. But that is not always true, because you can do the throttling of a request despite there is no rate limiting set. So throttling works independently. If you are attaching it with the rate limiting, great, that is the double layered security that you are going to provide. But if not, still throttling exists without rate limiting. So first discuss on the static part. So static, let's say you are setting a rate limiting policy 500 requests per second. CPU threshold is greater than 80%, or else let's say 200 concurrent users are allowed. So all these are like a static policy that is being set. What your system is going to do is, let's say there is a rate limiting controller and that rate limiting controller is monitoring, okay, it gets a request, it is let's say using a window or it is using a bucket, it is just counting those many number of requests till the time these policies are not breached. As soon as these policies are reached, as soon as the threshold is reached, it starts throttling the request based on whatever throttling model you have selected. Either you can do hard throttling, soft throttling or hybrid throttling. But this is what static throttling is. So let's say 500 requests per second is what your admin has set, but your system is able to handle 1000 requests per second, but he has set 500. So now your system is forced to do the throttling. It doesn't care whether your system can accommodate more requests or less requests. Again, like 200 concurrent users, maybe it can be possible like, okay, your system can handle 100 concurrent users or your system can handle 500 concurrent users. It doesn't matter. As soon as this threshold is reached, it is going to throttle. This is what static throttling means. Like, okay, just count the parameters, the request, and make sure like that is matched with the policy that you have set in the configurable. If that is reached, just throttle the request. That is what static throttling means. Then comes the dynamic throttling. Dynamic throttling means, okay, system in itself is smart enough to identify the issue and throttle the request. And again, like this is automated feedback loop. This is one type of an example using which system is going to throttle. So for example, let's take this diagram. Watch health of a system. If it is not good, invoke throttler. Again, watch health of the system. If it is not good, again throttle the request. Again, watch health of the system. If it is good now no action. Don't throttle the request. Relax. So for an example, let's say there is an IPL match that is going on live, and now it is expected like, okay, the live streaming that is happening, only 1 lakh users would be able to see at one time. Okay. And if more users are coming, we need to scale more servers. So now there is 1 lakh requests. They are getting the stream data. The client application, they are able to show the stream to the clients properly. The video quality is good. There is no buffering and everything is is fine. Now suddenly there is a spike and let's say 1,50,000 or 2 lakh users newly joined. So now the concurrent request for that particular stream of data has increased. My one server is not able to handle that because the configuration for one server is let's say 1 lakh requests per second. Now what is happening is, because there is so many requests that is coming, my server is not able to serve. So now the concurrency has happened. The different dimensions has kicked in. Let's say the CPU memory threshold has reached, the concurrent request that was set that has reached, the video quality or the response turnaround time has been slowed, the latency has been increased, the throughput has been decreased, whatever, like different dimensions are then those has kicked in. So now what happens is like now system decides like, hey, I need to scale the pod. For scaling a new pod, there is certain amount of time that is going to require. So now in that time, what system is going to do? It is going to play smartly. It is not going to decline those 1 lakh more requests that it is receiving, but it is going to decrease the streaming quality of the previous 1 lakh users. In that network bandwidth, it should be able to accommodate those 2 lakh users. So it is going to decrease till the time the new server is going to spin up. So now as soon as the new server is up, these 1 lakh requests are navigated, are transferred to that new server. So this is what it watches the health of the system. The system is getting choked up. So now what it is going to do is, the system health is not good, the network bandwidth is not good, it is going to invoke the throttler. The throttler is going to decrease the bit rate, decrease the video quality, the stream quality. The server is going to take this action, okay. It is going to decrease the video quality for the previous 1 lakh users, and again like it is going to continuously watch and continuously decrease and continuously watch, and this is going to go on as soon as the new server comes up. So now this new 1 lakh request is transmitted to that new server where it is watching the health. Now it is saying like, hey, in this network bandwidth attached to this particular server, now it is just requesting for 1 lakh users and not 2 lakh users. So now the health is good. Now it is not going to take any action. It is going to relax the throttle, and now it is again going to increase the video quality. So initially, let's say initially the video quality is 480 pixels. It has downgraded it to 240 pixels. Now everything is good. Again it is going to slowly increase to 360 pixels and then 480 pixels. So this is what automated happens. Again, like couple of examples, Kafka back pressure. So if you have used Kafka, so as soon as if there is a lag in the consumer consuming the data, it back pressures to the producer so that like it should push the data slowly. This is what Kafka back pressure. Again, like video streaming quality, I have told, let's say you are using a mobile phone and you are traveling, or you do not have a proper network coverage, or you are using let's say 2G or 3G kind of a network data. Here your bandwidth is low. When your bandwidth is low, initially when the client application is requesting let's say 480 pixels of a video quality, because it is monitoring, your client is monitoring like, hey, the bandwidth of the user is less. So now what it will do is like it will give a call to the server setting like, hey, my bandwidth is less and give me 240 pixels of a data or 144 pixels video quality. So this is now client side throttling that is happening. All this is like not set by any user, but this is automated that is happening. So this is what dynamic throttling is. So with this video, I guess so I have been able to explain you what exactly throttling means, different types of throttlings. If you feel like I have added something knowledgeable, so please do like this video, and please subscribe to my channel. Please comment if anything is there that I can help you with, or if something I have accidentally said wrong. Thanks for your time. Bye.